Right, here we have an area of a shape question, but unfortunately for us, we've got algebra in the sides rather than numerical values. It tells us the area of the shape, that is 351 centimeters squared, and it's asking us to show that this sum is true. The good news for these questions is that if you are able to get an answer like that, you know you're correct. So that's really nice sometimes to have that immediate feedback in the exam that you're correct. Area of a trapezium, you may well know it. If not, you have your formula sheet whereby it's given to you. Okay, picture of a trapezium here. We've got half a plus b times h. So I've got the formula that I wish to use, that is half a plus b times h, like that. Now we're going to substitute the values in that apply for this equation. And you may well actually do it with the trapezium. You may well wish to label it as it is in the diagram. So they've got A for the top side, A. They've got B for the bottom length. And they've got the distance between them of H. The distance between them is the same as this height here, this 2x. And then we can just simply substitute those values in. So we've got a half bracket the A, which is x minus 4. We're going to add to that the B part, which is x plus 5. X plus 5, close our brackets, so that's the A term and the B term, and we're going to multiply it by our H side, which was 2x. So this is going to need a little bit of tidying up for us first of all. We'll keep that part of the bracket. So in the bracket I've got an x plus another x, so I've got 2x, and we've got a minus 4 term here, plus 5. Minus 4 plus 5 is plus 1, and that's multiplied by 2x. Now I've got different aspects either side of my bracket, so I've got half times this times the 2x. So I'm just going to rearrange it to bring that 2x to the front. So it's a half times 2x, open brackets, 2x plus 1. A half times 2 is 1, so those cancel each other out, so I'm just left with x brackets 2x plus 1. Expanding the brackets, x times 2x leaves me with 2x squared. X times 1 leaves me with 1x, which we write as just x. Now this is how the area of a trapezium, how we work out the area. It tells us the area is 351. So I could have this whole time actually written 351 on the left hand side. Now that's not quite in the format they want to do. I've got the 2x squared, I've got an x, they got minus 351, and that's because they've got it equaling 0. So to make this equal 0, I'm going to have to take away 351 from both sides of my equation. So I'm going to have 0 equals 2x squared plus x minus 351, and that's in the format they want it, so I know I've got it right. That's 2 marks of my exam I have got right. Question B, we've actually got to work out the value of x. So even if you've looked at this question and you didn't have much of a clue what to do with part A, they've given you the equation and that's what they want you to solve. So I've got 2x squared plus x minus 351 equaling 0. Now this question is worth 3 marks. So I've got to do a bit of work here. Now when we're solving quadratic equations, which this is because it's got a square term, we've got some different options available to us. I can factorise it by putting it into brackets. I could sketch it out and see where the lines might meet the axes, but there's nowhere near enough room, I won't be able to do that accurately. Or I can use the quadratic equation. And given I've got this minus 351 term on the right hand side, probably indicates I'm not going to be able to factorise it that easily. The good thing is it's calculator paper, you have the quadratic equation given at the front. It gives you how it's written, so always prudent to write out what you've got. A equals 2, B equals 1, C is going to equal minus 351. Copy the term of the equation from the front. So minus b plus or minus the square root of b squared minus 4ac all over 2a. And what we're going to do, we're going to substitute the values of a, b and c into this equation and work it out. We're going to have to do it twice. Once with the plus symbol, and then we're going to replace the plus symbol with the minus symbol to do it for the second time. So I'm going to have minus b, we're substituting in. I'm going to have minus 1, because b is 1, plus or minus the square root of b squared, which is 1 squared, minus 4 times a, and a is 2, times c, which is minus 351. And already I could probably spot where some people make an error. It may make an error because there's a minus there and there's a minus 351, so that could prove problematic. That is all divided by 2a. A is 2, so it's 2 times 2. Right, this can now be put in my calculator. I could simplify it, or I could just put it all in as it is at the moment. Okay, in case I make an error, I'm probably just going to do it as it is at the moment. So I'm going to put it as, use the fraction button to write the numerator in, and then the second part. So I'm going to have minus 1. Now there is no plus or minus button. Okay, you have to do it once with the addition, as I mentioned earlier, and then once with subtraction. So if I do addition first of all, and I can do my square root and write all of this under the square root. So 1 squared minus 4 times 2 times minus 351. That's all under the square root. I can move then down into my fraction button and do 2 times 2 in the denominator. Press equals, and I get an answer of 13. So that is one solution for x. It could be 13. I now need to do it with the negative. Do not clear your calculator. Alright, really try and avoid clearing your calculator, because now I can go back up into this previous sum, navigate through it, and that addition symbol, I can just delete it and replace it with a subtraction symbol, and I'll get my other value, which is minus 13.5. So x equals 13 or minus 13. These are two values for solving this quadratic equation. However, they gave this in a scenario that this trapezium had dimensions. So this height of this trapezium was 2x. So it's 2 times 13 is 26. We can't have 2 times minus 13.5 because its length is not minus 27. You can't have a negative length. It is going to be a positive. So although it gives us two solutions, the one that really we want is that x equals 13 to finish the question.